If you're looking for a RAG tutorial with Langchain and Python, then this video is for you. In this tutorial, we are going to look how to build RAG using Langchain, all the tools you need, writing clean code using OOP object-oriented programming language, and finally running our RAG retrieval augmented generation on Gemini as well as on open source model like Llama 2. RAG are used in businesses to solve real-world problems, in hospitals to provide medication help, and in many other places. Hello everyone, my name is Zaid Ghaffar and I'm super excited to be your instructor. Now RAG connect our models like GPT, Gemini, and any other open source model with external data sources. Now these external data sources can be in the form of PDF, documents, databases, and web APIs. I have divided this complete RAG tutorial in 7 main steps. Step number 1, we need to load our documents. Step 2, we need to divide it into smaller chunks. Step number 3, we need to use our embedding model and convert these chunks into embeddings. Now don't worry, we will discuss what actually are embeddings later in the video. Step number 4, we need to store these embeddings into our vector database. Step number 5, we need to load our vector database. Step 6, we need to search for our relative query. And last but not least, we need to pass our information to our large language model. Let's jump in and start our tutorial. First of all, I want you to open your command prompt. For this, type cmd. Here, type cd ... to move out from a folder. Again, inside of our C drive, I'm gonna make a new folder named as RAG. So for this, you need to type make directory or make dir. Afterward, click enter, go inside it, and open your VS Code. Here, create a new file named as main.py, and inside of it, I'm gonna create a new folder named as datasets. Here you put all of your PDFs and all of your dataset inside of it. Press enter. Next, I want you to open this link. I will provide it in the description. Here you can see different types of disease, their symptoms and their conditions. Click on it and download it. Do for the others. So first copy it and paste it inside of your datasets. So here, paste it. So our first thing is to create an environment. For this, type python/mvenv and type the name of your environment. Wait for seconds. Now move inside your environment in environment. Here you need to activate it. For this, type ./scripts scripts and activate it. After activating your environment, you can see that there is a green button inside of here. Next, what you need to do is install some couple of dependencies. For this, type pip install. First dependency is for Langchain, that is third-party library. Next, we have our Langchain/community, and last but not least, FIAS. This is a vector database. Install for it. Next, as I have already told you that I'm gonna build this complete code with the help of OOP, so define our class name as RAG. Define your constructor here, _init, pass here our keyword self, and here pass. Next, create an object of our class. For this, type RAG. Here you need to pass 3 parameters. First is our path_data, the path to our dataset. Next we have our path to our vector database for DB, and last but not least, you need to pass your query here. So take all of these here, copy the path, full path and paste inside it. Next again paste inside of it, and for this type I'm gonna do vector DB. Last but not least, as I have already told you that I'm gonna build this for hospitals, so let's type what actually is acne. What actually is acne? Let's ask it a question. Save, pass these keywords as parameters. So type self dot path underscore data equals to path underscore data. Again self dot, this time persistent directory equals to path to our vector database. Last but not least, self dot query equals to our main query. So our first step is to load our documents and read it. For this, create a new function known as load underscore documents. Pass here keywords. Our next step is to import from Langchain underscore community dot document underscore loaders. I'm gonna import for PyPDF directory loader. So here loader equals to PyPDF directory loader and pass here our path. In my case, we have our self dot path to our dataset, so we have our path underscore data, and last but not least, put self dot documents equals to loader dot load, means that load our dataset. You can print up here your documents or the length of your documents. So we have our self dot documents. Control S to save and run it. As you can see that we have our document successfully loaded. Next our next step. Okay, now our next step is to convert this large document into smaller chunks so that our large language model can understand it. So type out, create a new function and text splitter, call it text underscore splitter, ter splitter, pass here self, and here first of all I'm gonna call it from Langchain underscore text splitter, import for recursive text splitter, recursive character text splitter. Here we have our self dot text sorry, spelling mistake, equals to, we have our recursive character text splitter and pass some arguments here. We have our chunk size of 1000, chunk overlap of 200, and length and all the other stuff. Okay, next we have to call a self dot chunks equals to self dot text text and dot split underscore documents. Here you need to pass self dot documents, our original documents here, and for checking purposes call print f-string here, and here from length of our self dot documents to our self dot length of our self dot chunks. Okay, let's call our function down here. I've already called it and run it. Hit Ctrl S to save and run it. Before moving ahead, I want to let you know that anyone could set up a Zoom meeting with me for an hour, discussing about their projects, their questions, fixing code in the field of artificial intelligence, and ask any questions for me. The pricing will be $15. I will provide my number in the description. So without wasting your time, let's jump into the tutorial.
you already know what embedding vectors are, then feel free to skip this section entirely. Otherwise, I'll give you a really quick explanation just to bring you up to speed. Embeddings are vector representations of text that capture their meaning. In Python, this is literally a list of numbers. You can think of them as sort of coordinates in multidimensional space, and if two pieces of text are closely related to each other in meaning, then those coordinates will also be close together. The distance between these vectors can then be calculated pretty easily using cosine similarity or Euclidean distance. We don't need to do that ourselves though, because there's a lot of existing functions that can do that for us already. And this will give us a single number that tells us how far these two vectors are apart. To actually generate a vector from a word, we'll need an LLM, like OpenAI. And this is usually just an API or a function we can call. For example, you can use this code to turn the word apple into a vector embedding. And this is the result I get from using that function. So you could see that the vector here is literally a really long list of numbers. And the first number is 0.007 something something, but I truncated the rest because the list is quite long. In fact, if you print the length of the vector, you could see that the list has 1,536 characters. So this is basically a list of 1,500 numbers. The numbers themselves aren't interesting though. What's really interesting is the distance between two vectors themselves. And this is quite hard to calculate from scratch, but Langchain actually gives us a utility function to compare the embedding distance directly using OpenAI. So it's called an evaluator, and this is how you can create one. And here's the code to run an evaluation. So here I'm comparing the distance of the word apple to the word orange. And running this, the result is a score of 0.13. So we don't actually know whether that's good or not by comparing an apple to an orange, because we don't know where 0.13 sits on the scale of other words. So let's try a couple of other words just to see what's a better match with apple than orange and what's a worse match. Here, if I compare apple to the word beach, it's actually 0.2. So beach is further away from apple than orange is, I suppose because one is a fruit. So that naturally makes it more similar. Now, if I compare the word apple to itself, this should technically be 0 because it's literally the same word. But in this case, it's close enough. It's 2.5 times 10 to the minus 6. Now, what about if we compare the word apple to iPhone? In this case, the score is even better than when we compared it with orange. The score is 0.09. And this is really interesting as well because in our first example with apples and oranges, they were both fruits, so they were similar in that respect. But here, we're sort of interpreting the word apple from a different perspective. We're seeing it as the name of the company, Apple, instead. So when you compare it with the word iPhone, the association is actually much stronger. So now that you understand what embeddings are, let's see how we can use it to fetch data.
So our next step is to convert our chunks into embeddings. For this, from Langchain .embeddings, first you need to import for Hugging Face BGE embedding. Okay, take a look at the name, and next here we need to do create a new function, and we need call it as get embedder. So we have our embedder model here, embeddings. Okay, and we have our Pasiga keyword self. Next here you need to paste a line which is known as embedder and Hugging Face embedding, and the model I want to use sentence transformer, and this is the model that I want to use for converting it to our embeddings. Next here we need to do self dot embed chunk underscore embeddings BEDDINGS embeddings should be equals to embedder dot embed underscore documents. Here it only takes one parameters on the list of chunks, so we need to convert our chunks into a list. For this, self dot text underscore chunks should be equals to, we have our pass it as a list, so we call it chunk dot page underscore content for chunk in our chunks self dot chunks. We take all the chunks and pass up here. Okay, self dot text underscore chunks. Next, let's check it worked correctly or not. For this, type here converted to embedding successfully, converted to embedding successfully as you fully, and okay, now at last we need to return our embedder. So embedder, Perfect. Let's call this function and run it. Object dot get underscore embeddings and call it. Hit Control S to save and run it. As you can see, our code runs successfully and converted into embeddings or numerical form. Next, we need to do from Langchain, we need to store it into our vector database. For this, from Langchain dot, we have our vector stores import for files, F-A-I-S, files. This is our vector database. Now, create a new function here and call it as BFF and embeddings to embeddings BEDDINGS underscore to underscore our database. Pass here a keyword self and pass. Okay, perfect. Now here we need to check if not os.path os. For this we need to import our os and here import for os. Give it some space, move down, and here os.path.exists. If the path doesn't exist, but path self.persistent directory, if it doesn't exist, then make it one. os.make directory and call it as self.persistent directory. Okay, next we need to store it into our vector database. For this, we have our self.database should be equals to our files, FAIS, files dot from underscore documents, and this take two parameters. First our chunks, self.chunk underscore embeddings, and the next our embedder model. So for this we need to call our embedder model, and here EMBEDDER embedder equals to our self.get embeddings. So this function gonna return our embedder, which is this, and we will go and pass it up here, embedder. Okay, next we don't want to store it again and again every time we run a program. We want to save it on our local computers. For this, type self.database.save underscore local and pass your here self.persistent directory where you want to save your folder or save your files. Okay, next print database saved successfully. Okay, next type here and boom, let's call this function here object dot we have our embeddings to vector database and hit Control S to save and run into an error saying that we can't pass self.chunks here as a list. For this you need to pass here self.chunks. Okay, self.chunks I think might be chunks, so for this chunks. Okay, hit Control S to save and run it once more. Okay, as you can see, our code runs successfully. Here we have our embedding created successfully and saved to our database. Let's check it. Control B, and you can see our vector database is stored in our local computer. Now we need to load it. For this, create a new function, load underscore database, and our vector database. For this, self, pass a keyword self and Control B to here. And here we need to paste a line. For this self.database, we have our files load underscore local, means that load from our local computer, and self.directory, we paste our link here or what is the path of your vector database. Next, the Hugging Face embedding model, same as the allow underscore dangerous underscore deserialization, means that you are allowing for giving some permissions to it. Okay, next check it if it runs successfully or not. Vector database loaded successfully, loaded completely. Okay, and here okay, perfect. Let's call this function here object dot not the self. Here we have our load underscore database and hit Control S to save and run it once more. You can see our vector database is loaded completely. Next, what we need to do is search for our documents. Search underscore documents, pass here a keyword self, and here we need to call it as create a new variable known as retriever. Retriever should be equals to our, what should be the self dot So we have our self dot database dot as underscore retriever, means that convert it into a retriever, and retrieve for what we need to pass up here. Search for most similar, for which we have our most similar 6 points. We have our most similar 6 documents that is most similar to our documents. For this, our retrieved document, retrieved underscore document should be equals to our retriever dot invoke, means that ask for a question. For what question? We have our self dot query here, ask for our query, and print our answer here. For this, retrieved underscore documents takes the 0 index of it and only print the page content. Next, call this function object dot search underscore documents. We don't need, as our database is already stored into our local computer, we don't need these some functions. For this, we don't need load documents, text splitter, get embeddings. We don't need this, so comment it down and hit Control S to save and run. You can see our vector database project completely, and it is asking for our query. So tell me what actually is, once again, what actually is acne, and ask it a question. You can see how much fast it is. Acne is the most common skin disease. We can type what are the type of acne, cause what are the types of acne. Here you can see whitehead, plus hair fossils. These are the types of acne and all the other stuff. Okay, you might be wondering that why we write it with the help of OOP, object-oriented programming language. The reason for that is here you can just upload your new documents here in datasets and run it one more time. Just uncomment these functions and run it. Your new document should be created. So that here we created a complete pipeline of our RAG, retrieval augmented generation. Now a client comes to you, or some other person will come to you and say that, hey, that build me a new RAG system. You don't need to code from scratch. You just change here in datasets, just delete all the previous file and store the new PDFs here. So this is why we got it with the help of OOP. Create our environment and install some more dependencies. First we need to install for, so pip install for Langchain underscore Google underscore Gen AI, and the second dependency is for Google underscore, we have our generative AI. So these are the Langchain for running our Bard, Google Bard or Gemini Pro model. So let's hit enter and run it. Okay, we have installed our dependencies. Now we need to import some couple of things from Langchain underscore Google underscore Gen AI import for chat Google generative AI, I think generative AI, yeah, generative AI, yeah, that's the thing. Okay, now also import for Google dot generative AI as Gen AI. Now below here we need to create another function for running our model, so call it as our model and pass the keyword self here. Okay, here we need to pass our API key. For this, API underscore key equals to, so this is my API key. Okay, you need to pass 2 parameters. We have our Google underscore API underscore key and then your API key. Next we need to call create a new variable, called it as LLM, means that large language model, and here you need to pass chat Google generative AI and pass some parameters. Sorry, let me copy these parameters and paste up here. Okay, so we need to go here, hit Control C to copy and move back. Here you need to pass these things. First of all, we have our model, what should be the model of Gemini Pro. So we are using 1.5 flash latest models. It is super fast than any other existing model. Then we have our verbose equals to true, means that give our answer in details. This is what our verbose is for, and temperature is for creativity. This is between 0 to 1, so I choose creativity of 0.1. Next we have our API key, so we need to pass our API key. Yeah, you can get it for free on Google Bard or Google Gemini Pro. Okay, next we need to ask it a question. For this you can do LLM response equals to we have our LLM dot invoke invoke. This invoke word means that ask a question, ask for what questions. For this I need to import for one more thing here. I have already imported it from langchain.prompts.prompt import for prompt template. So what it does, let me show you. Here I'm gonna create a new function, and okay, you can see that self.prompt_template should be equals to prompt template, and template equals to hey, I found some information for you. So pass here your retrieve documents, and then we have our kindly read it carefully and then answer the following questions. Okay, so what questions we have given here? Our query. Okay, we can pass here our self.query here also, self.query. Okay, next what we need to do here is remove it. We need to convert this prompt template into string. So for this we can do retrieve underscore document underscore content. The content should be equals to, for every line we need to give it an empty space dot join, and join for what thing. So for I want to join it with the list of our documents. So for this doc dot page underscore content content, and what should be the doc. So we can do for documents in retrieved underscore documents. Okay, so here you can see, and pass this self.retrieved document, make it self.retrieved underscore content to our prompt template. So here we have our prompt should be equals to we have our prompt template. So prompt underscore template. So let's copy it, self.prompt template, self.prompt underscore template dot format, and here we need to pass through two things. First is our retrieve documents. So we have our retrieve retrieved, I think this is a spelling of underscore documents equals to, so we have our self dot, we need to pass here a string of our document. So we can do self dot retrieve underscore document underscore content, and next we need to pass our query here. So query should be equals to self dot query. Okay, one more thing I want to confirm here. Let me see, retrieve underscore document, copy it, Control C to copy, and let's paste up here so that we don't get into some trouble. And sorry, Control C to copy, and here Control V to paste. Okay, perfect. Now I have removed this search documents, and now here we can print our response. So let's run it one more time. We didn't print the response for this. Here you can print our response and print for the response. Perfect. Run it. Hit Control S to save and run it. Okay, here you can see we get into some errors. We need to convert our query into a string. For this you need to pass just your query here, not the self keyword. Hit Control S to save and run it one more time. Let's run it and wait for it. Okay, just run it one more time. Okay, let's ask a question. What actually is acne? What actually is acne? And let's wait for its response. Super fast. Okay, here you can see how much fast it is. The Gemini Pro, it's so super fast. It tells us acne is a common skin conditions that happen. Okay, one more thing that you can do for your RAG system is that instead of passing single paragraph, we can pass multiple paragraph in order to improve the quality of our RAG. So for this, just remove it and paste up here. Here I'm saying that convert my query into embeddings into numerical form. Next, what we are going to do is that search our vector database by similarity underscore search by vectors, means that search by our vector. For what vector I want to search for, I'm going to search for query embedding, and last search for most common 3 points. Then you can just look through it and pass this page content self.documents to our Google Bard or in our prompt template. So just remove it and pass to our Bard, and it's definitely gonna work.